Geologic Maps, Part 2C, Construction of a section through a geologic map showing a fault. Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious, the most merciful. Assalamu alaikum wa rahmatullah. The subject of this series deals with geologic maps. In Part 1, an overview of geologic maps and structural features will be presented. In Part 2, construction of geologic cross-sections will be given. 4 structural features have been considered: simple dipping beds, a nonconformity, a fold, and a fault. Construction of a geologic cross-section through a map showing a fold. The adjacent figure shows a hypothetical geological map in which 4 sedimentary rock units, A to D. The map scale is 1 to 10,000 and the contour interval is 100 meters. It is required to find the strike, true dip, and to draw a cross-section along the line XY. The length of the section line XY is 18 centimeters. To draw the strike lines, trace each of the contact surfaces between the bits which appear as lines AB, BC, and CD, and mark the points of intersection between each of the contacts and the contour lines, the small circles on the map. Then, join points of the same elevation for the same boundary by a straight line. In this map, which shows folding, one may mistakenly attempt to join, for example, the points shown within colored boxes on the basis that they have the same elevation and on the same boundary. However, one must keep in mind that the definition of the strike line assumes intersection between a plane surface and the horizontal plane, whereas along the middle strip of the map, the beds are bending. Thus, joining points of equal elevation across the bend may show non-parallel strike lines, and/or the same line connects different boundaries with the same elevation, which is illogical in parallel planes. Accordingly, one must be careful in drawing the strike lines in such cases. By joining points of the same elevation for the same boundary of all the beds, 2 sets of parallel strike lines are obtained. Extend one of the strike lines from each set to intersect an arrow of north direction and measure the angle. In this case, the angles are equal in both sets since the strike lines are parallel. It is 4.5 degrees, thus the strike is north 4.5 degrees west. Write near one end of each strike line the symbol of the contact surface and its elevation value. To determine the direction of dip in each set, find the direction of decreasing strike line values of one boundary. Erect an arrow perpendicular to one of the strike lines in the direction of dip for each set. The average spacing on the map between 2 successive strike lines of the eastern set is 1.45 centimeters, whereas the average spacing of the western set is 2.6 centimeters. The value of true dip θ1 of the eastern set of bits may be determined from the equation tangent θ1 equals strike interval over spacing times scale. By substitution, this gives 100 over 1.45 times 1 over 100, which gives 0.69. Therefore, θ1 equals 34.6 degrees northeast. The value of true dip θ2 of the western set of beds may also be determined from the same equation. Tangent θ2 equals 100 over 2.6 times 1 over 100, which gives 0.385. Therefore, θ2 equals 21 degrees southwest. Superimpose an edge of a strip of paper on the section line XY and mark the location of the points X and Y. Mark the intersection points between the line of section and each of the strike lines and write 3 strike line values for each boundary. Superimpose the edge of another strip of paper on the section line and mark the locations of the points X and Y and the intersection points between the section line and the topographic contour lines together with their elevation values. Superimpose a third edge of strip of paper on the section line and mark the locations of the points X and Y and the intersection points between the boundaries and the section line. On an ordinary graph paper, draw a line segment whose length equals that of the section XY. Erect two vertical lines from the two ends, X and Y. The horizontal scale along XY equals that of the map. Let the vertical scale equals the horizontal scale. Put centimeter marks on the vertical lines. 1 centimeter equals 100 meters. Put the strike line intersections strip of paper on the graph paper. For each boundary, erect vertical lines from its strike line marks with their heights corresponding to their elevations. Mark their ends, then join them by a straight line which will represent the boundary whose values were projected. Thus, by erecting vertical lines from the strike line marks of all the boundaries, then connecting points of each boundary by a straight line, the following figure is obtained. Extend the lines of the same boundary from each side towards each other with gradual deviation until they meet, forming an arc. Put the edge of the second strip of paper on the section line and from each intersection point erect upward a vertical line whose height corresponds to its elevation value and mark its end. Superimpose the boundary intersection point strip of paper on the section line and from each boundary point erect upward a vertical line to cut the corresponding boundary. Draw the profile line by connecting the surface elevation points. Make any necessary modification to ensure that the profile line passes through each of the boundary intersection points and extend it from both sides to reach both ends of the section. Erase all the contact lines that lie above the earth's surface and any unnecessary vertical lines and points. Put the symbols, coloring, and name of each bit as in the following set of figures, and the section is done. This is the end of part 2C. Next, part 2D, construction of a geologic cross-section through a map showing a fault. With my compliments. Assalamu alaikum wa rahmatullah.